Hello. Hello.
Hello, sir.
Hello, sir. Good morning.
Good morning. Actually, I'm going to start class now. Okay. I'm going to discuss some problems also. Okay. I will share the screen. Okay. Screen is visible, no? My screen is visible, no?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. I'm going to solve some problems today on functions. How to find the inverse that I'm going to explain. And I will give written notes also. Nothing to worry. Okay. Whatever I discussed so far, I will give that one also. Okay. Some additional information is there in notes. You can read it. No problem. Okay. Today I'm going to solve some problems. Obtain. One request is that you should maintain notes. Okay. You take on 200-page notebook and whatever the problem I am solving in the class. Okay. You should take that to your notes. You're understanding now what I am telling.
Yes, sir.
Yes.
Okay, you
Yes,
should
sir.
not write it on a page and because page you are writing means you are throwing somewhere. Okay, you purchase one notebook. Okay, if you are writing on pages means at least you staple it and you have to keep that notes in a file or somewhere. Okay, in the order that then that becomes useful at the time of exam. Okay, if you are writing it in a notebook means it is good. Okay, you have to take this problem. I will tell you how to find the inverse mathematically. Obtain inverse function of obtain inverse function of here two problems are there. Okay, f of x is equal to x cube. You should have to find the inverse of this one, and the second one is B. B is this one. Sorry, second problem. I can say like this: f of x is equal to x cube plus. For example, you see, inverse means like this. So suppose the graph is there like this. Okay, okay, some graph I can say this is f of x. If we know f of x, we can find the inverse. The inverse means the corresponding value of x. For this value of x, this is the height. For this value of x, this is the height. For this value of x, this is the height like this. Okay. If you know the function, we can find the corresponding value of x. You should find the inverse like that. Okay. In set theory, we are explaining like that. F is a function from the set A to B. Then f inverse is a function from B to A. Okay. So inverse exists when a function is bijective. So inverse, how do you find? I have to take, for solution 1, you take f of x is equal to y is equal to x cube, y is equal to x cube. You tell me what is x from this one. What is x? X is equal to cube root of y. Am I right? Now you change x. This is the rule. X is changed to y and y is changed to x. So what you will get? This x will become y. X will become y. See, this is the step. X will become y. Y is equal to cube root of x. So this cube root of x is there. No, this is actually f inverse. Therefore, f inverse is equal to cube root of x. F inverse is equal to cube root of x. So like this, we can find the inverse of a function. This is actually f inverse. Okay, see, it is like this. Suppose the element of x, the image of x is f of x. Its pre-image, how do you find? Like this, we are finding pre-image. It is cube root of x in this case. Okay, in this case, it is a cube root of x. You can understand like this. Okay, you can understand with one example this problem. See, this is a f. What is f? F is this one. F is equal to x cube. So what is the image of 1? 1 cube is 1. What is the image of 2? 2 cube is how much? 8. What is 3 cube? 3 cube is 27. Okay, correct now. So pre-image means it is like this, f inverse. What is the pre-image of 27? Now it is like a x. Understanding now? So the pre-image of 27, how do you find? It is cube root of 27. Correct now? Cube root of x is 27. In my case, reverse case, this is. What is cube root of 27? It is 3. You got it now? You are understanding or not? You tell me.
Yes, sir.
Yes, sir.
This is given, f is given x cube. Is asked to find f inverse. F inverse is like this, cube root of x. See, how do you solve it mathematically? I will explain. You see, y is equal to x cube is there. You have to take f of x is y. Y is equal to x cube. What is x? X cube, x is cube root of y. After that, you change x to y and y to x. So you will get a cube root of x. So this cube root of x is nothing but f inverse. Okay, you can understand with this example. Okay. You write one example and otherwise you are not understanding the concepts. Okay, through examples you should have to understand. Okay, this one also you should have to find. How do you find this one? F inverse. F of x is y. Y is equal to x.
Y is equal to square root of x minus 2.
No, you write first x cube is equal to y minus 2. What is x? X is y minus 2 with cube root, correct now? Cube root of this, correct now? Now you change x to y and y to x. What you will get? Y is equal to cube root of x minus 2, correct now? So this is actually f inverse. This is actually, this will become f inverse. So where to write? So okay, space is not there. I'll show you arrow mark here. From here to here. Okay. So this F inverse is much it is the cube root of x minus 2. Okay, like this we are finding F inverse. So if it gives any function, we can write its function without any difficulties. Okay. Okay, I'll write F1. So next I'll going to start, the function is over. Next I'll going to start this one, inverse of function. Okay, the left hand limit and limit concept, left hand limit and the right hand limit. Actually I discussed it many times earlier. So left hand limit. So what is the left hand limit? See, I am going to explain it graphically. Suppose this is graph. Okay, this is a function f of x. Okay, when this f of x tends to some L. Okay, this is L. Okay, x is this one. Okay, this is the functional. Okay, this is a functional value at x, at this point x. Okay, when x tends to a, when x tends to a, this is the point a, I can say. So what is left hand side limit? When x approaches this point from the left hand side, then that is called a left hand limit. Understanding now? So the limit when x tends to a, f of x is equal to L. If it exits, then this is called a left hand limit. Understanding now? What is the right hand limit? What is right hand limit? Similarly, right hand limit. Right hand limit. Right hand limit. This one also I can explain it graphically. See, okay, this is a graph like this. Okay, somewhere here, this is a function f of x. I can say this is the height at the point x. Okay, and this height I can say L. And when x tends to a, so x is a at this point, it is this is sorry, this is left hand or right hand? This is correct, no? Left hand. Okay, left hand limit. What is right hand limit? So when x tends to a from the right side to this point. Okay, so that is called right hand side limit, right hand limit. So how do you write this one? When limit x tends to a, f of x is equal to some L, I can say. This is called right hand limit. Okay, so we are approaching this point from the left hand side here. It is a left hand limit. Here we are approaching this point from the right hand side. This is the right hand limit. If it exits and if it exits means this is called right hand. We can say right hand limit exits and left hand limit exits. Okay. So now I'm going to take one problem. You tell me what is the left hand limit and right hand limit for this one. Okay. Example. Are you understanding this one? Any difficulties here? Any difficulties?
No, sir.
No, sir.
Because I think you solved many problems in PU level. Okay. In CET and JEE for exams. Okay. These problems are not difficult for your level. 2 less than x less than or equal to 4. So this is the problem. Let f of x, our function is like this, piecewise function. Then find the limit for okay. You have to understand this concept. See, most of the time we are using limit. Limit x tends to 0 like this. Understanding? No, this not. Instead of LIM, I am writing most of the time LT. You should understand this notation. Is it clear? LT means limit. Okay. While writing, you write LIM. Huh? Is it clear?
Okay, sir. Yes, sir.
I am writing LT. You can write LIM. Okay. Our teachers taught this one LT. So for limiter, I am writing LT. So you write LIM, no problem. Limit extends to 0. LT limit extend. So this is my notation. You can use it, no problem. Limit. You should have to find this one. Limit of f of x when x tends to 2 plus. 2 plus means right hand side limit, and the limit x tends to 2 minus. Okay. So how do you find this one left hand limit when x tends to 2 plus? So the right hand limit. What is right hand limit? You tell me. Right hand limit. Limit f of x when x tends to 2 plus. Correct now, right hand limit.
Yes, sir.
Tell me what is right hand limit. What is right hand limit? What is the answer?
Sir, 3.
3.
Correct. Actually, right hand limit is 3. Why it is 3?
So because for the function for greater than 2, the value for x greater than 2, it's given in the question is 3.
Yeah, 2 greater than is given. We are approaching from this side. Understanding? No. So it will becomes 3. Okay. Similarly, what is the left hand limit? Limit extends to. Okay. Now, naturally, we can say what is the answer? Okay, 2 minus. So what is the answer? Limit when extends to 2 from the left hand side. Left hand side means this side. Suppose if you are approaching like this means it will become what? Actually, this is f of x. So it is limit extends to 2 minus f of x is this one, x minus 3. Okay. Understanding now? See.
Yes, sir.
We are approaching from right hand side means this is here we can't take this as x minus 3 because is equal to 2 is there. We need to take greater than 2. So we are approaching from greater than 2 side. Okay, greater than 2 side means this interval only. Okay, from this notation you should understand. Okay, from which interval we can approach that point. Okay. So here this is the case, we can approach this 2 through this interval. So 2 to 4. So when x tends to 2 minus, so in this case, what is the answer? It will become x minus 2. What is x minus 2 now? What is x minus 2? X minus 2 is minus 1. So in this case, the left hand limit is not equal to right hand limit. Okay, the function is not continuous actually at that point 2. Okay. Okay, this is over.
Sir, sir, can you explain last 2 steps?
This one, huh?
Sir.
This one. See, function approach. X approaching 2 plus means. See, it is greater than 2. Greater than 2 means that is in which interval? 2 plus means. From the right hand side, we are approaching 2 means, and we are taking. Okay, okay, through graph you can understand. Okay, you plot the graph. When x is equal to 1, what is 1 minus 3? What is 1 minus 3, you tell? When x is equal to 1, when x is equal to 1,
-2.
minus 2. So minus 2 no, somewhere here, correct no? When x is equal to 0, x is equal to 0, no, it is a minus 3. Okay, this point, the graph is going like this. When x is equal to 2, when x is okay, screen is visible, no? Screen is visible, no? Hello?
Yes, sir.
Okay. Okay, when x is equal to 2, what is 2 minus 3? It is a minus 1. Okay, somewhere here. Okay, the graph is like this. Okay. Next, when x is equal to 2, so when x is equal to 2, it is exactly, it will become 3. 2 to 4, I can say. Okay. So I can say this is x is equal to 2. When x is equal to 2, the graph is like this. Actually, this is x minus 3. Okay. Through graph you can understand. Okay. Here break is there here. Break is there here. This point I can say x is equal to 1. When okay. When x approaches from left hand side means it is approaching from this side. Understanding, no? This side you are approaching means actually this is the graph x minus 3. So this is the graph f of x is equal to x minus 3. Okay, sorry, this is not the case. So f of x is equal to, what is this one? X minus 3. Correct? Now this is the graph you will get. When x is equal to 2, you will get this one. What is that one? 2 minus 3 is minus 1. Okay, this is the graph. When x is equal to 2, from the right hand side, you see, when x is equal to strictly greater than 2 means, this is the graph actually. Strictly greater than means 2 to 4, your graph is like this. When x tends to 2, okay, 2 minus, so 2 minus from you are approaching 2 from left hand side. From left hand side, you are approaching means you will get this value. Understanding, no? From the right hand side means, you are approaching. So somewhere the x is here, x is equal to 4. So x is equal to 2. So 2 plus this is 2 plus means you are approaching from this side. Right side means when you are approaching from right hand side means there is a break for this graph and this graph. So you are approaching from the right hand side here. So what is the value of f or a function? It is 3. F of x is 3 here. Understanding, no? When you are approaching from this side, it will becomes what? It will becomes put 2 here. 2 minus 3 is minus 1. Understanding, no? See, left hand limit, left hand limit, for left hand limit is minus 1. Okay, and the right hand limit is 3. Right hand limit is 3. Both are not equal. Therefore, the function is discontinuous. Is it clear now? Any doubts here?
No, sir.
No, sir.
Huh?
No,
Any
sir, no
doubts?
doubts.
No doubts. Okay. Then no problem. You draw the graph. You can understanding becomes very simple. If you know the graph means understanding becomes easy. Okay. You sketch the graph. Anybody can understand through graph. Okay. Geometry definitely helps you to understand many things. Okay. Okay. Next, which concept actually I took? Okay. Here I'll take. One minute. Next heading, the limit of the function. The limit of the function. See, limit of the function means here both left hand limit and right hand limit exists. To L. This is right hand limit and this is okay, A minus you can write on the top. This is left hand limit. Both are exits and L is the limit of this L is called the limit of the function f of x as x tends to A and is this one. So limit of the L is the limit of the function and both are exits and both are equal. So that is the case we can write the limit x tends to A f of x is L. Understanding now? See, limit of the function. So L is the limit of the function. Here left hand limit is equal to L and right hand limit is also L and both are exits and same. That is the case we can write the limit x tends to A f of x is equal to L. Okay. So L is the limit of the function. Is it clear? Next to
Yes, sir.
okay, is this clear? Limit of the function here. L is the limit of the function. So L is the when do you say L is the limit of the function? Both left hand limit and right hand limit exist and both are same and this is equal to L. Okay. Next to one more definition is there for a continuous function that is called epsilon delta function. One minute. Okay. Or you take some more examples on limit only. Am I solved this type of problems earlier? Am I solved? Because I took class now for you.
ಪತ್ರಕರ್ತರಿಗೆ ನೀವು ಮಾಡಿದ ಅನ್ಯಾಯಕ್ಕೆ ನಾವು ಕೊಡ್ತಾ ಇರೋ ನ್ಯಾಯ ದಟ್ ಈಸ್ SP ಸಾಂಗ್ಲಿಯನ ಶ್ರೀಕೃಷ್ಣ ಪರಮಾತ್ಮ ಸೋಮ ಸುಂದರ್.
ಯಾರಪ್ಪ ಅದು? You mute your mic. Okay, you take this example. Here you have to find a limit for this one. Okay, so find the limit x tends to 2 x cube minus 8 divided by x minus 2. Okay, so how do you find the limit of this? When x tends to 2 cube is 8 minus 8 is 0. So 0 0 over this is 0. It will become 0 by 0 form. Okay. So how do you evaluate this one? How do you evaluate this one? We can use the L'Hospital rule or directly also we can evaluate it. This you already knows. And limit extends to 2. How do you write x cube minus 8? A cube minus b cube. X minus 2 into x square plus 2x plus 2 square. It is 4. I am using a cube minus b cube formula over x minus 2. Okay, otherwise you can use the L'Hospital rule. When x tends to 2, 2 square plus 2 into 2 plus 4. So what is the answer? Answer is 12. Like this also we can evaluate. See, you take another function. When you take another this function, I will tell you actually its behavior is very nice. Find for all these problems I will send a notes today only. Find limit and return notes. Find the limit of the function f of x sin pi by at x tends to 0. Okay. What is the limit? What is the limit value of this one when f of x is equal to sin pi x when x tends to 0? Anybody knows the answer? Anybody knows the answer? See, I will tell you how actually it behaves. How the graph is behaves. This is x-axis and this is y-axis. See, when x approaches the 0, this point actually it is going like this. Graph is like this. Nearer the point when x tends to 0 means when x tends to 0 means this sin pi x how it behaves. Actually, it's going like this up and down. It is going. Okay, very difficult to understand. It is nature. So here it is plus 1 and it is not. It is minus 1 here. So it is oscillating between minus 1 and minus 1. So what we can say here, what we can say here, limit exists for this function. This is the case. It is going like this. So when x approaches this side, it is graph is like this. And when x is going this side means the graph is like this. When x tends to 0, the graph is like this. So nearer x tends to 0, the graph is like this. It is going up and down here. Okay. In this part it is this part it is this part plus 1. Echo is coming. You have to mute your mic. First. Okay. So oscillating in minus 1 and so limit x tends to f of x is equal to the limit x tends to 0 sin pi by x. When x tends to 0, you will not get a finite value. So it is oscillating between minus 1 and plus 1. You can say does not exist. Does not. You can say does not exist. Okay. Hello. Am I
Yes, sir.
audible?
Yes, sir.
Yes, sir.
Audible, no? Why do you
Yes,
say
sir.
the limit does not exist? So, can you answer to this question? Can you answer to this question? Already written everything, but you should do some justification to this one. You give justification to this one. See, limit of a function means this is the definition. When limit extends to a plus f of x is equal to some L. Limit extends to a minus a plus this is a minus, correct, no? So f of x is equal to also L. So limit is a finite. Okay, understanding whether it is a left hand limit or right hand limit, correct? No, here what happens when we approaches from left hand side also, it is going to plus 1 or minus 1. If we are approaching from this side also, right hand side also, it is going to 1 or minus 1. So limit value is not finite here, it is oscillating, correct? No, limit exists means it is single value, whether it may be a left hand limit or right hand limit L. Okay, it is L. Here you are not writing plus or minus L, understanding, no? Just L you are writing, not plus or minus L. So only one L, not plus or minus L. So here what you will get, here plus or minus 1 you will get. So what we can say, limit does not exist. Understanding now? What is the limit of the function says? See, when x tends to a plus f of x is L and x tends to a minus under right hand left hand limit also it is L. Then both are equal and we can say L is the limit of a function f of x. Okay, here both are not equal. Sorry, even left hand limit also not exists. Right hand side limit also does not exist because it is oscillating. Okay, you look at the definition of this one, limit of a function. From that concept we can say limit does not exist for this function. Okay. Any doubts on this? Any doubts?
No, sir.
You draw the plot by using a MATLAB software. You draw the graph 1 by x. You see the behavior when x tends to 0. You see the even, okay, from x is equal to 2 to x is equal to minus 2 you can plot, or by hand only you can do. So how the graph behaves when x tends to 0. 0.2 you have to take, 0.001 you have to take, 0.0001 you have to take, and you see the graph. You are understanding actually how it is behaving when x tends to 0. Okay. Next to Heaviside function. Next, another example. Heaviside function. Have you heard this one? Heaviside function. It is very useful in electrical and electronics engineering. Heaviside function. Okay. So it is denoted by h of t. Instead of x, I am going to take h of t. So how it behaves? It is 0 if t is less than 0, and it is 1 if t greater than 0. Okay, I will draw the graph also for this one. When t greater than 0 means this is the graph. Okay, t greater than 0, and when t less than 0, negative means it is 0 only. The h of t is the height. H of t means it is height. When t is negative means it is 0 only. H of t is negative. Sorry, 0. Okay. In this case, what is the left hand limit and right hand limit? When limit x approaches the 0, 0 minus, I can say. What is h of t? It is 0 only. Limit x tends to 0 plus. Suppose if we are approaching from this side, what is h of t? You tell me. H of t is this height only. What is this height? Height is 1. H of t is 1. So it is 1. What we can say? So left hand limit is not equal to right hand side limit. Left hand limit is not equal to right hand limit in this case. Okay. So this is called Heaviside function, and it has many applications in electrical and electronics engineering. Okay. You have to understand through graph. Through graph only you have to understand left hand limit, right hand limit. It becomes easy also. Okay. h of t does not exist. So limit of h of t does not exist. Why limit of h of t does not exist? Because left hand limit is not equal to the right hand limit. Okay, so we can write limit of h of t does not exist. So does not exist at t is equal to 0. At t is equal to 0. Because left hand limit is not equal to right hand limit and t tends to 0. Okay. I will give another example. For this one, the limit exists or not, you tell me. Okay. Let next problem. Let f of x is equal to the mod x. Correct? No. Then find the limit of x tends to 0 f of x. So our given function is mod x. Tell me whether the limit exists or not. You tell me. Find left hand limit when x tends to 0, right hand limit when x tends to 0.
Sir, limit does
Sir,
not
exists, sir.
Limit exists or not?
Sir,
Limit exists
does
means
not.
left hand limit is also finite, right hand limit is also finite, and both are equal. That is the case, we can say limit exists for the given function. Otherwise, we can't say. Okay, you already see the previous example. In one example, it is oscillating between -1 and +1. In another example, you will get 0 and 1. Left hand limit is 0, right hand limit is 1. In this case, you see. You find left hand limit and right hand limit quickly for this one. You find left hand limit and right hand limit. What is left hand limit and what is right hand limit for this case? See, x greater than 0. So minus x if x less than or equal to 0. Okay, x greater than 0 means actually this is a mod function. You get a line here. When x greater than 0, this is the case. X less than 0, this is the graph you will get. Understanding? No? When limit x tends to 0 minus left hand side, we are approaching means the mod x is equal to the limit x tends to 0 minus mod x is minus x when x is approaching from this side. When x is approaching from this side, this is a minus x. Correct? No?
Yes, sir.
Okay. X tends to 0 and mod x is minus x. When x tends to 0, it is 0 only, we will get the left hand limit. Right hand limit. When limit x tends to 0 plus the mod x. So the limit x tends to 0 plus the right hand limit means x is approaching 0 from this side. So this is the graph x. With just you write x, the mod x will become x. When x tends to 0, it is 0. Both are equal. Okay, both are equal. You should write limit of x tends to 0 plus the right hand limit of mod x is equal to limit x tends to 0 minus mod x. This is the left hand limit. Both are equal and is equal to 0. So you can write limit of a function exists. You can write limit x tends to 0, the mod x is equal to 0. So you can think answer to my question quickly. Okay. For all these problems, I will give handwritten notes, nothing to worry. So f of x is equal to this one, 2 minus x, x minus 1 whole square. It is f if x is less than minus 1, if minus 1 less than or equal to x less than 1, if x greater than or equal to okay. Screen is visible, no? Screen.
Yes, sir.
Hello. Screen is visible. Okay.
Not
See,
now, sir.
this is the given function.
No, sir,
Okay,
no.
this is the given, not visible. Huh?
So now it is
Now it's
visible.
visible, sir.
1 minute.
Visible, sir.
Now it's visible, sir.
Visible, sir.
Oh.
Okay. Okay, this is the given function. Okay. Now we have to evaluate the limit of this function, the given point. 1 minute. If you are not understanding means you have to quickly ask, no problem. Okay. See, in an online mode, so due to network busy and other some related other problems, okay, very difficult to give continuous attention also. Okay, my question is this one now. Then find the limit of x tends to minus 1 f of x, okay, and limit x tends to minus 1, sorry, minus 1 and sorry, x tends to plus 1. For this one, when x tends to minus 1, x tends to minus 1 means what is the value of this one? Limit x tends to minus 1 f of x, where it is there in this interval, it is there. X can approach us minus 1 in this interval. Okay, this interval. So what is left hand limit? You tell me. What is left hand limit?
3.
Huh? Tell me. It is 3, correct. Limit extends to, you find both, for -1 means you find both left hand limit and right hand limit. So -1, okay, I write -1 only. When extends to -1 from left hand side, on the top you can write minus. Okay, our function is okay, f of x. F of x is 2 minus x in this case. Limit extends to -1, left hand limit. So you write minus on the top. It is 2 minus x. So put x is equal to -1. So it is 2 minus of -1. So it is 3. Okay, this is left hand limit. Is 3. What is right hand limit? Extends to -1 only from the right side. From the right side means which one we will going to take? This interval.
Sir, x,
Understanding? No?
x.
Yes.
The -1.
F of x. If you are not understanding means for all 3, you should write a graph and you can see. Okay. When x tends to -1 from the left hand side, when x tends to -1 from the right hand side, what you will get? So you draw the graph and see in the same intervals. Okay. -1. So limit x tends to -1. F of x is x, and that is equal to -1. Correct, no? Okay. So the what is left hand limit is 3, and right hand limit is, what is left hand limit? This is left hand limit.
-1. -1.
Right hand limit is this one. Are these two are equal?
No, sir.
So these two are not equal. Here left hand limit is not equal to left hand limit is not equal to right hand limit. What we can say here is us to find limit of f of x extends to -1. For this one you should have to evaluate left hand limit and right hand limit. Here we can say directly limit does not exist. Okay, therefore the limit of extends to -1 f of x does not exist. Does not exist. So one more problem is there. Limit extends to +1. What is the answer? What is the answer when extends to 1? Both when extends to 1. What is the answer?
So 0, 0 and 1, sir. Limit does not exist for this also.
It does not.
Yes, sir.
Hello, in first case limit does not exist. The second case, when you see this extends to -1 on the left hand limit, right hand limit you are checking. When extends to 1, for this one also you should have to check left hand limit and the right hand
Yes,
limit.
sir.
Sir.
So
Sir, limit does not exist for x.
For the second case as well.
The limit does not exist.
limit does not exist.
Exists.
Okay. Limit does not exist, so, but we need justification also for this one. Okay,
Sir,
similarly, the limit, okay, your answer is correct. Limit extends to 1 plus 1 for notation, left hand limit, I am writing -1. Okay, f of x. I am approaching +1. I am approaching +1. Left hand side means in this interval it is coming. Understanding, no? This interval corresponds to x. Correct, no? So that interval corresponds to x. So I can write like this. Limit extends to 1. Left hand limit you write minus here x. So when extends to 1 it will become 1. Okay, this is left hand limit. Limit extends to 1, right hand limit, this is f of x. So extends to 1 means right hand side means right hand side means it is greater than 1. Greater than 1 means this function x minus 1 whole square. Understanding, no? So you write limit extends to 1. Graph is there means very simple. Okay, left hand limit, right hand limit, we can explain that very without any problem. Okay. Some students are not understanding if I explain it mathematically. Graphs are there means you draw the graph and you analyze these things. So it becomes very easy. Okay. Right hand limit means I am approaching this one from greater than 1. Understanding now? So this is the function, corresponding function. So 1 means put 1 minus 1 is 0. In this case, right hand limit is 0 and the left hand limit is sorry, this is 0 and it is 1. Left hand limit is not equal to right hand limit. Understanding now? So what you can say? Limit does not exist, sir. Correct now? Limit does not exist, sir. ಜಾಗ ಚೇಂಜ್ ಮಾಡ್ತೀನಿ ಒಂದು ನಿಮಿಷ 11:15 ಎಷ್ಟು ಬರಲ್ಲ 2 ಬೆಳಿಗ್ಗೆ ಇದಿಲ್ವಲ್ಲ ಅದು ಎಕ್ಸಾಮ್ ನಡೀತಾ ಇತ್ತು ಒಂದು ಮಿನಿಟ್ So you should write the limit does not exist, sir. Okay. So limit extends to 1 f of x does not exist. Okay. 1 minute. I have to wait. Understood now? You all understood now? Any difficulties here?
No, sir.
Okay. Okay, screen is visible now?
Yes, sir.
Yes, yes,
Okay,
sir.
okay. I'll take two more examples. Then I'm going to discuss the loss of the limits. Actually, for this one, you can refer some PU problems also, no problem. Actually, for limits, okay. I think you solve this type of problems from PU, in PU textbook only many problems are there on the limits, okay. Okay, you take this problem, you find limit also. Find limit t tends to 0, root of t square plus 9 minus 3 divided by t square. So now how it looks? 3 square root of
Sir, your voice is breaking.
t tends to 0.
Sir, your voice is breaking.
The root of okay. 1 minute. Okay, maximum sound is there. I think due to bad network, I think it is happening. Am I audible now?
Yes, sir.
Yes, you're audible.
Okay. T square now audible now. T square plus 9. Sometimes due to bad network. So you are also facing network problem. I am also facing a problem here. So t root of t square plus 9 minus 3 divided by t square. So this is the case. You should rationalize this one. Okay. How to rationalize this one? So rationalize this denominator term. Rationalize the numerator term. It is t square plus 9 minus will become plus 3. With the same term, you should have to multiply root of t square plus 9 plus 3. Okay. This is of the form a plus b into a minus b. So you simplify this one. Okay. Okay. You should. I can write. Right. I will going to write this as some given expression. Okay. Given expression means this one. Okay. Now you simplify this one. So what is the given expression? The given expression is equal to product. This is of the form a plus b into a minus b. What you will get? A square means the root of t square plus 9 whole square is t square plus 9
minus 9
minus b square. Minus b square is minus 3 square divided by t square into root of t square
Root
plus
t
9
9
plus 3.
plus
Okay,
3.
close the bracket. You write a limit t tends to 0. So here what happens when t tends to 0? Sorry, here 9 minus 9 it gets cancelled. Actually, what is there here? In numerator it is t square.
T square upon t
Denominator
square gets cancelled.
gets cancelled. It is root of t square plus 9 plus 3. Okay. Here you should write limit t tends to 0. Limit t tends to 0. T square gets cancelled. When t tends to 0, what happens? 0. It is root of 9. Root of 9 is root of 9 plus 3. So 3 plus 3. What is the answer? It is 6.
1 upon 6.
So the given expression is equal to 1 by 6. Okay, limit of this function is equal to 1 by 6. Okay. And some laws are there. Laws of limits also we are going to discuss. Okay, for those who are understanding the concept of limit, right, directly have to evaluate the left hand limit and right hand limit. Okay, if we have some problem we are facing, okay, means you draw the graph and you can evaluate. That is very easy. Okay, for your understanding, you draw the graph and see. Okay, you can find left hand limit also, right hand limit also without any doubts. Okay. Okay. Limit loss or loss of limit, or you can say limit loss. Limit loss. Okay, well, the left hand limit, how do you write? Limit extends to a. This is the notation for left hand limit. F of x is equal to L. This is left hand limit. Okay, this is left hand limit. We are writing like this. Similarly, right hand limit, how do you write? Right hand limit extends to, this is the notation, a plus. Okay, f of x, it is also L. Okay, both are exits and equal. That is the case, we can say limit exits. So laws of limits I will tell you. First law, when limit extends to a is there, functions are there, f of x and g of x, sum of two functions. How do you evaluate this? Limit is outside. Okay, I can write limit extends to a. How do you write this one? We can separately apply the limit. This is the concept. Limit extends to a, f of x plus limit extends to a, g of x. Understanding? It is similar to that of integration. Integration of some two functions are there, x square plus sin x. Okay, like this. So we can operate this integration on both the terms. Correct? No, integration of x square into dx plus integration of sin x dx, like this.
Yes, sir.
Okay. Similarly, second limit f of x minus g of x. Okay. Extends to a, f of x minus limit extends to a, like this. So minus is there, means we can apply a limit on each function like this. Limit extends to a, g of x, like this. Okay. Third one, some constant into limit extends to a, some constant into this one, f of x. This is the case we can write like this: c into limit x Screen is visible now? Hello?
Yes, sir.
Okay. Suppose the function is like this product f of x g of x, so product. It is like this. That is the case. We can apply the limit like this. The limit extends to a f of x, okay, into the limit extends to a g of x, okay. And the last one, sorry, fifth one, when limit extends to a f of x by g of x, this is the case we can write like this. Limit we can apply numerator, we can apply this limit it on numerator separately, denominator separately. Limit extends to a f of x numerator, you write limit extends to a denominator, okay. Okay, these are the laws of limits, okay. So plus is there also, we can apply the limits it on each term. Minus is there also, we can apply the limits on each term like this. Some constant into function is there means c, you have to take it outside and apply the limit for the given function. Product is there in an individual function, you should have to apply limits. So if it is of this form, f of x g of x form means limit you can apply numerator, denominator separately, okay. So these are all called the laws of the limits, okay. Next actually the definition of the continuity. Continuity, when do you say the given function is continuous at the given point a, okay. So I'll discuss it in later in the next class. I'm going to discuss the continuity concept also. So continuity, so here the left hand limit extends to a f of x, both are exits, limit extends to a minus f of x, both are exits and both are equal. This is left hand limit and this is right hand limit, both are exits, left hand limit to both and right hand limit, both are exits and is equal to L. That is the case, we can say given function is continuous at the point A. Given function is continuous at the point A. Okay. So in the next class, actually, I will continue this one. So now I will take attendance and close the class, end this session. Okay, I'll close the session. Okay.
Thank you, sir.
Okay, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.
Thank you, sir.
Hello. Okay, I will send the
Yes,
notes
sir.
in the group. Okay, I will send the notes. Okay, thank you. Thank you.
Thank you,
Okay,
sir.
sir. Thank you, sir.
Thank you, sir.
Yes.
Thank you, sir.